So basically, let's start with symmetric with respect to a line.
Okay, so if something, and this is a definition, if something is symmetric with respect to a line, then
I always say that the line perpendicular bisector of the segment connecting the 2 points.
okay, so symmetry with respect to a line, then the line that connects 2 points has a perpendicular bisector between them. Okay, lots of garbage. Okay, so if two lines, let's say we are on a graph, this is easiest to see on a graph, okay? So if I put this line here, or this point here, and this point here, okay, then there is a line of symmetry between them, because if I connect these 2 points and I put the perpendicular bisector in there, this line is the line of symmetry. It's the line of symmetry. Now basically what that means is I could fold it at that line and the points would match. Okay, so that's how I kind of look at it. It's the line where if we fold, then the 2 points would be on top of one another. Now, that's kind of basically what a line of symmetry does. This is between 2 points, but we can do the same thing with figures. So if we looked at, let's just look at a triangle. If we have an equilateral triangle, okay, how many lines, can you find one line of symmetry? Now this is supposed to be equilateral, okay? So what would be a line of symmetry where if I fold it on that line, it will actually be a mirrored image, they will match up, yes?
If the top angle was bisected.
Okay, if we just bisected this, which actually gives us the perpendicular bisector of this, okay, then that would be a line of symmetry. So we can draw one line of symmetry in there. Is there another way we could do that? Is there any other lines of symmetry? Yeah.
Any of the other angles.
Yeah, we could flip it around and do any of the other angles, right? So I could do this angle here. That's a line of symmetry, and I could do this angle. Whoops, that wasn't very good. I didn't bisect. I could do that angle there. Okay. So that triangle actually has 3 lines of symmetry. So this would be 3 lines of symmetry. In other words, there's 3 lines I could fold it on and I would have an exact mirror image. And I'm not going to worry about all that. So that's really what lines of symmetry are, is we're looking at that. We are going to extend line symmetry next week into finding lines of symmetry on the graph like this. for different items and actually finding the equations for those. So we will be finding equations on coordinate graph. This is not in your book.
So do only equilateral triangles have 3 lines of symmetry?
Well, that's a good question. Is that true? Do only equilateral triangles are they the only ones that have 3 lines of symmetry? Let's look at an isosceles triangle. That's not isosceles. Let me make it skinnier. That looks too equilateral. Okay, we're gonna go like this. There's my isosceles. How many lines of symmetry does that one have?
1.
Yeah, I saw your one. Yes, the only line of symmetry it has is down that way. Yes.
So basically, the only time it will have 3 is when all the angles are 60 degrees.
Yes, basically that's true. Okay, but we're gonna find the equations for the line of symmetry on a coordinate graph. So this is gonna be something that is not in your book. This is how I'm incorporating your algebra, advanced algebra into this. Okay, and so that's what we're gonna actually be looking for in there. Okay, this will be something next week. So next week, if you don't see any notes you have to take, it's because I'm gonna be talking to you about things that are different that are not in the book. Okay, and I'll have to give you a special worksheet to calculate those because we don't have problems like that in the book. Okay, so that's basically that's everything about section 6.1. The only other thing is you can do constructions. They talk a little bit in here about constructions of perpendicular bisectors. We already know how to do that. We've done perpendicular bisectors before. Okay, so between the 2 points, then you would have to find the perpendicular bisector with construction to get the actual accurate line of symmetry. But for the most part, I just want you to be able to identify it. And then we are going to actually find equations on a graph because that's a little more useful than just trying to construct it. Okay, so and so that's really all of 6.1. So we're going to go on to 6.2. Okay. 6.2 now is very much about parallel lines. That's the title of the chapter, or the section, which is also the title of this whole chapter. Okay. Okay, lines parallel. Okay, so how do I know that 2 lines are parallel? Yes.
They never intersect.
Yeah, that's correct. 2 lines, parallel lines. That's not spelled right. There we go. Lines never intersect. So if they never intersect, what does that mean? Can you say anything about if I have 2 lines and they're supposed to be parallel, what is something I know about them? Yes.
They're never gonna cross.
They're never going to cross. That's true. That's what this means. But what else do I know? If I draw lines that go through here,
The same.
here, and here, they're the same distance apart, right? Okay. So the distance of perpendicular lines, or perpendicular lines between the parallel lines never changes. It's always the same, but the distance in here is always going to be the same. So that's really what that's saying there, okay? So that's one way to look at parallel lines.
Now, with parallel lines,
They love to do these things, and just looking at parallel lines. So with parallel lines, any line that cuts through both, but because we want to see more, but any line that cuts through both parallel lines is called a transversal. So a transversal is a line that intersects with both lines that are perpendicular. I mean parallel. Okay, so these lines are parallel. So these two are both parallel. This is called the transversal, so that's what the setup is of a transversal. A transversal can be any line that cuts through those. Now, the simplest one is the perpendicular one, but it doesn't show the things I want to show you as well, because perpendicular would make it all right angles, and it's pretty much very easy to see that all of them are the same. So we're going to use ones that are not right angles. So we're not using the perpendicular ones, okay? So when we have parallel lines, there's a whole bunch of things that we can find out from that, okay? And so we need to name, this one's a lot of names, okay? And which ones are the same size. Usually by looking at them, you can tell what ones are the same size. But there are special names for those. And so that's what we have to go through. So let's draw our picture of two lines with a transversal. From that, we are going to make some definitions. Okay, here's my two parallel lines. Okay, these are parallel. Oh, by the way, if I call this A and this B, a way of writing that is A is parallel to B. That is the way to, this is the symbol, A is parallel to B. Okay, yes.
Are they transversal if the line is in between them? Or does
No,
have
it has to
through?
go all the way through. Yeah, yes.
Is this 6.1 or 6.2?
This is 6.2. Sorry, I didn't change that. Sorry, this is 6.2. When we get to the line parallel up there, it was 6.2. Okay, so here I'm going to cut it. That line is my I'm going to call it C. That's my transversal. Okay, when I cut it, let's look. 1, 2, 3, 4, 5, 6, 7, 8 angles appear. You guys see that? See all 8? Okay. No, let's number them.
Oh,
I have 1, 2, 3, 4, 5, 6, 7, 8. 8 angles that we have there. They all have special meanings. Okay. Yeah, it's very interesting. Does anybody see vertical angles? Give me a pair of vertical angles. Any of them? Yes.
I can't see one and the other.
I can't
One.
see one.
No, 1 and 3.
Okay, 1 and 3 are vertical. Aaron, give me another set.
6 and 8.
6 and 8 are vertical. Micah, give me
5 and
another set. Okay. Harrison, give me the last set.
2 and 4.
Correct. So vertical angles, you have 4 pairs of vertical angles. So one thing is vertical angles. In this situation, you have 4 pairs. Okay. So that's one thing to remember. This actually helps us to figure out which angles are equal to each other. Okay. So, So there's 3 different kinds of angles. One are called alternate interior angles. We have alternate exterior. Oops, that's not how you spell exterior. And we have corresponding angles. Okay, these all deal with those 8 angles that we have up there. Okay, and part of it is learning just how to identify it. By the way, all of these, when you're looking at them, just a minute. Yes, okay. All of these are congruent when you're talking about them. So all alternate interior angles are equal, all alternate exterior angles are equal to each other, and all corresponding angles are equal to each other. So I will give you how you find what corresponding alternate interior and alternate exterior means. Okay? So if you look at alternate interior, alternate means on different side. What alternate means is, if you think about alternate, it's on the opposite side of the transversal. So alternate means that the angles are on different sides of the transversal. It's kind of like when you alternate between one side and the other. That's what alternate can mean. We're alternating between one side and the other. Interior means they're in between the 2 parallel lines. So interior means these angles are in between the parallel lines. That's interior, inside the parallel lines. Okay, so based on that, we are looking at these angles. These are my angles that are inside, correct? 3, 4, 5, 6 are inside, in between, okay? So alternate interior would be 3 and 5 because they're on different sides. So angle 3 and angle 5 are congruent because they're alternate interior angles. They are equal, okay? That would also mean that 6 and 4, they're inside, okay? They're on opposite sides of the transversal alternate. You're alternating sides. So 6 and 4 are also congruent. So that's what we know about alternate interior. But how to find them? Interior means they're inside the parallel lines. Alternate means they're on different sides of the transversal. Okay? So what does alternate exterior mean? What do you think? Yes?
They're outside the parallel lines.
They're outside the parallel lines and they are
Alternate.
they're alternate. They're on different sides. So outside parallel lines and different sides of the transversal. Okay, Luke, give me a pair of alternate exterior angles on this drawing.
It'd be like 1 and 3.
Hmm.
But 1's inside, so
Yeah, so we want the ones that
it would
are,
be 1 and 7.
yes, it would be. Okay, so we want to be outside, so we're actually dealing with 1 and 2, 7, and 8, because those are our outside angles.
Alright, yeah,
The alternate ones would be 1 and 7. Okay, what's my other one, Jake? What's the other alternate exterior pair?
3, 2, and 1.
Think about outside and opposite. So it has to be on outside. One's outside the other one. Yes, David.
2 and 8.
Yes, 2 and 8. So they're outside. Okay, and they're an alternate side. So angle 2 is congruent to angle 8. This only works, don't take these for always. This only works if your drawing is labeled like this. Okay, make sure this only corresponds to that. I don't want you to think, oh, I can just look and say 3 and 5 are the same. No, that's not true. It has to be labeled like this. Okay, so the last one is corresponding angles. Okay, and this one is where you have one interior, one exterior. Yes.
1 and 3.
No, those are vertical angles, 1 and 3. Okay, so let's look at corresponding. Corresponding is well, let's put it, how do I say? Yeah, one exterior, one interior. One exterior, one interior, and same side of the transversal.
So like 1 and 4. But that won't work.
No, because
1 and 6.
Oh, it'd have to be. So they're both, yeah, transversal. Okay.
So like 1.
So when I talk about one exterior, one interior,
So it's
if they're below line A, so one is below, or so they have to be in the same position. So if it's same position on both parallel lines.
so like 1 and 5 or 2 and 6.
Yes. Both lines. That is right in parallel.
So it can be corresponding to something else while at the same time being a different.
Yes,
line.
yeah, it can. Yeah, we're just showing you all the relationships and what they're called. Okay, so this one, when I talk about an exterior angle, there's one exterior angle. It's below B. So the interior angle has to be below A. Okay, so it can't be this one. So it's 1 and 5. So that's why I said they have to be in the same position on both lines. So if 1 is below B, 5 has to be below A. But they are on the same side of the transversal. So pairs angle 1 is congruent to angle 5. Give me another one. David.
8 and 4.
8 and 4, yes they are. Corresponding. Okay, give me another one, Paxton.
7 and 3.
7 and 3. Okay, and give me the last one, Luke.
2 and 6.
2 and 6, yes. Okay, so what's interesting is there's 2 alternate interior angles, okay, 2 pairs. There's 2 pairs of alternate exterior angles, but there are 4 pairs of corresponding angles, just like we had 4 pairs of vertical angles. Okay, so we can see vertical angles, alternate interior, alternate exterior, and corresponding in that picture. Okay, what a pain. Oh, I'm sorry. Okay, what would be 1 and 4? What are they called?
Angles.
Yes, they are. So what's the relationship between
Oh.
angle 1 and angle 4?
They're a linear pair.
They're a linear pair, so that means these 2 added equals 180 degrees. So look for also linear pairs.
Yeah, a lot of these are linear pairs. Actually.
Yeah. Okay, so that's something to look for. Now, if I want to prove that these angles or these 2 lines are parallel, I have to prove that one of these sets is parallel. Okay, so I have to prove that two alternate interior angles are parallel, then that will tell me that the lines are parallel. I have to prove that two alternate exterior angles are parallel, that will mean the lines are parallel. If I find two corresponding angles that are identical, that means that they are parallel, okay? If the vertical angles doesn't work, I'll just tell you that. That doesn't prove anything, because I can have vertical angles and it doesn't mean they're parallel, okay? So when we're trying to prove or show, if we don't know if two lines are parallel, that's the question, you have to show one of these is true. Okay, so that's kind of the key thing. If I'm trying to find out that they are parallel, you have to find an alternate interior angles that are equal, or an alternate exterior angles that are equal, or corresponding angles that are equal. Okay, and so that will help you to prove that they're true. Okay. Okay, that is basically the whole section here. Now we'll try some problems.